Hello everyone, welcome to Learnedze. Today in this session we are going to look after one of the most important security features of a switch, that is DHCP snooping. In modern networks we often see firewalls, IPS. From the end point of view we see antivirus, anti-malware softwares as the network security measures. In order to understand the modern security risk, we have to understand the rules first. Then we have to look after how an attacker can take advantages of these rules. Here in this video we are going to check how an attacker can take advantages of the rule DHCP and how he can put himself in the network as a man in the middle and able to copy the information from a legitimate host, and how this DHCP snooping features of a switch can act as a security measures for this man in the middle attack. DHCP plays vital role in almost every network today. By almost every end user point uses DHCP services to get its IP address, subnet mask, default gateway and DNS server. Now let's understand how a DHCP works and how a PC can assign the IP address information automatically by using the DHCP services. So DHCP works in 4 steps: discover, offer, request and acknowledgement. Now let's take this subnet and understand how the PC1 gets its IP address information automatically from the DHCP server present in its local subnet. Now the PC1 will perform these steps in order to get the IP address information from the DHCP server that is present in its local subnet. Now in the first step, the PC1 will send one discover message, which will be a broadcast message in its local subnet asking, hey, is there any DHCP server out there who can lease me IP address? So this broadcast message will be flooded over all the devices in its subnet. When this discover message reaches the DHCP server, the server will reply with an offer saying, yes, I am a DHCP server and my IP pool range is this. So I can give you the IP address from my address pool. Now PC1 will get the offer reply from the DHCP server. Now the PC1 will request another packet to the DHCP server asking to assign a particular IP address. So once this request will get by the DHCP server, then DHCP server will reply to that request with an acknowledgement by sending one IP address. Let's say it will send 192.168.1.2, send it as an acknowledgement to PC1 saying that here's your IP address, and it will send the related information like default gateway, DNS server to the PC1. So that's how, by using DHCP process, that is discover, offer, request and acknowledgement, a PC can learn its IP address information from the DHCP server present in its local area network. Now let's just understand how an attacker can enter into the network and take advantages of these services. In order to assign IP address by SDHCP server, the server needs to have unused IP address left in its IP pool. Otherwise, the DHCP server will not be able to assign IP address to a particular host. Let's say here in this subnet, an attacker tries to enter the subnet via switch, and let's say the attacker flooded over the DHCP server with hundreds and thousands of DHCP discover messages. Now when the DHCP server will get those discover messages, it will try to reply all the discover messages, and eventually the DHCP server will exhaust its IP pool while replying to those discover messages. Now the attacker's PC will introduce another rogue DHCP server into the network. Now in this scenario, let's say a new PC tries to find out an IP address automatically from a DHCP server asking, hey, is there any DHCP server out there? Since our genuine server has exhausted all the IP addresses from its pool, now the rogue DHCP server will reply to this new PC saying, yes, I am the DHCP server and here's the IP address for you. So it will assign an IP address to the new PC, and what the attacker ROG DHCP server will do, it will assign the default gateway IP address as the attacker's PC's IP address. That means the new PC default gateway will become 192.168.1.7, which is nothing but the attacker PC's IP address. Now, in this scenario, whenever this new PC tries to serve the internet, then the PC will send an packet to the gateway. That means this packet will come to the attacker's PC via switch, and the attacker will copy that packet for the further processing, then reroute this packet to the router R1. Then router R1 will transfer this traffic to the outside the network. When the reply will come to that request, the router 1 will send this packet to the PC2, which is nothing but the attacker's PC. Now the attacker's PC will get the reply to each packet, so it will copy for further processing, and again it reroute the packet to the new PC. So that's how the attacker will act as a man in the middle in this network and getting each and every packet that is flowing in the network, and he can look over those packets and he can use those data for manipulation and unethical work. So that's how a man in the middle attack can be happen by using the advantages of the DHCP services. Now let's check how we can prevent those attacks by using DHCP snooping. We can prevent man in the middle attack by enabling DHCP snooping features in a switch. By configuring DHCP snooping features in a switch, we will tell the switch that which port to trust for the DHCP offer reply. That means after configuring DHCP snooping in this switch, the switch will look after the DHCP offer reply, and the switch will only allow the DHCP offer reply from the trusted port. All the untrusted port, if they tries to send an DHCP offer reply, this packet will be discarded by the switch. So that's how we can prevent the man in the middle attack by using DHCP snooping. Now let's check this whole process in a practical way in the packet tracer scenario. So here in this scenario, we are going to understand the DHCP snooping. Let's consider this network where R1 is a genuine DHCP server having IP pool from 192.168.1.2 to 192.168.1.254 and having default gateway of 192.168.1.1 and DNS server address of 8.8.8.8. I have already configured this IP address in this router 1z0/0/0 interface. So currently these three PCs are working in my network, and this PC will get the IP address from my DHCP server, which is router R1. So in the first step, that is step number 1, we are going to check whether this PC will get the IP address from this router R1 DHCP server or not. Then in the step 2, what I will do, I cannot show you here in the packet tracer scenario the DHCP attack. So what I will do, I will limit this range to only 3. That is, only 3 PC will get the IP address. After getting 3 PC, router R1 DHCP server will not be able to provide DHCP IP addresses to any other host. After that, since router 1 now cannot provide IP address information to any of the hosts, in step number 3, what I will do, I will introduce this ROG DHCP server, which is nothing but an attacker's DHCP server, to the switch of the network. Now, this network will have two DHCP server, one is router R1, another is attacker's DHCP server. And now the router R1 has exhausted its IP address ranges. So now when I introduce new PCs in the network, these attackers DHCP server will try to reply to this new PC and try to assign the IP address to this new host. Then after that, in the step 4, what I will do, I will configure DHCP snooping in the switch. Then I will check what will happen if there is a new PC comes into the network and tries to get the DHCP IP address. Which server will reply to that IP address? Now let's perform these steps one by one. Now let's configure this router R1 as a DHCP server. For that, let's write down enable configure terminal, then change the hostname to R1, then write down IP DHCP pool, write down the pool name, that is, let's say ABC, then write down the network 192.168.1.0, subnet mask is 255.255.255.0, and write down the default router will be 192.168.1.1, and the DNS server for this entire DHCP network will be, let's say, 8.8.8.8. Now let's write down the AND command and write down the show run command in order to verify the IP DHCP pool. As you can see over here, the DHCP pool has been created. Now let's go to the PC1, PC2 and PC3 and let's check whether they will get the DHCP IP address from this router R1 or not. For that, let's click on the DHCP. As you can see, the PC1 is getting IP address from router R1 and it is getting the default gateway from router R1's DHCP. Similarly, let's check the PC2 and PC3 also. As you can see, all the PCs in the network are getting the DHCP IP address from the router R1. Now let's move to the step number 2. Now in the step number 2, let's say there is an attacker come into the picture and he flooded this router R1 with n numbers of DHCP discover messages, and the router's R1's DHCP range will become exhaust. So here I cannot show you the attack here. So what I will do, I will go to the router R1. I'll go into its global configuration command, and here I will exclude all the IP addresses. So for that I will write down IP DHCP exclude address. So from the PC3, the last IP address was 192.168.1.4. So from 192.168.1.5 to 192.168.1.254, I will exclude all the IP addresses. So now you can say that an attack has been occurred in the our genuine DHCP server, which is router R1. We can check by using show run. So only 3 IP addresses available for DHCP to assign the host, and all the 3 IP addresses has been assigned and other IP addresses I have excluded. That means there are no IP address left for the DHCP server to assign a new host, right? So now the next step will be, we'll configure this ROG DHCP server, which will be nothing but an attacker's DHCP server. So let's say it has an IP address of 192.168.1.1 and subnet mask, and it will have a default gateway of 192.168.1.7. Now let's configure this DHCP server. For that, let's go to the service, then DHCP, then turn on the service of DHCP, and let's configure this time this attacker's default gateway as 192.168.1.7. So this 192.168.1.7 IP address will be attacker's IP address, and we are configuring this DHCP server to provide this as a default gateway to the new host. Let's say DNS server is 8.8.8.8, and let's say this DHCP server will assign the IP address from 192.168.1.20 to 100 numbers of PC. Okay, then click on save. Now we have successfully configured the attacker's ROG DHCP server. Now let's introduce this attacker server into the network, and let's see what will happen when a new PC tries to connect to the network. Now in this step, this genuine server is being under the attack by the attacker, and the attacker has introduced an ROG DHCP server into the network. Now let's say when this new PC that is laptop 3, tries to have IP address via DHCP command, this time this rogue DHCP server, which is nothing but a attacker's DHCP server, will respond to it. As you can see here, it got the default gateway of 192.168.1.7. Suppose the attacker's PC have this 192.168.1.7 IP address, then for this new PC, the attacker's PC will be the default gateway. Now in the next step, what we will do, we will configure the DHCP snooping command in this switch. For that, let's go to the switch, then let's go to the switch CLI and write down the enable command, go to the global configuration mode, and I will tell the switch to trust only at the FA0/1 port for the DHCP offer reply. So I'll go to the interface FA0/1 and I'll write down IP DHCP snooping trust command, so that for the DHCP offer reply, it will only trust the FA0/1 port. Now I will enable the DHCP snooping in the switch. For that, I'll have to write down IP DHCP snooping command. Then I'll have to write down IP DHCP snooping VLAN 1 command, since every port is a part of VLAN 1. Then we have to write down no IP DHCP snooping information option command. This command is related to the DHCP relay agent, so we will not go much depth in this session. Now we have successfully configured this DHCP snooping in this switch. We can check by using show IP DHCP snooping command. As you can see, we have configured first Ethernet 0/1 port for trusted for DHCP offer reply. So the switch will only respond for the DHCP offer reply that will come from this FA0/1. Now let's go to the victim PC, victim laptop, which was earlier attacked by this rogue DHCP server, and try again the DHCP request, and let's check this time from which they will get the IP address. As you can see, our genuine DHCP server has excluded the IP address range, and now this time this rogue DHCP server cannot reply to this PC because we have configured DHCP snooping over here, so the DHCP has failed. Now if I go and if I remove the DHCP IP address that are being configured earlier, let's go to this victim PC again. This time I will try to request one DHCP from this PC. As you can see over here, this time this PC is getting the IP address from this genuine DHCP server. Okay. Similarly, what we can do, we can connect this new PC into the switch and we can check for the DHCP IP address over here. But before, let's remove all the DHCP IP address from the previous PC. Now this genuine DHCP server has IP address available in its IP pool. Now let's try to communicate by using this new PC and try to assign IP address by using DHCP. Now this time you can see this PC is getting the IP address from the genuine DHCP server, so it is not getting reply from the rogue DHCP server. Similarly, same with this PC also. So this is how we can configure DHCP snooping in the switch, and we can check the DHCP information in the switch by using this show IP DHCP snooping binding command. So by using this, you can see that the IP address 192.168.1.3 is connected to the FA0/6 and it has a MAC address of this as shown in the table. So this is an important table from the DHCP snooping point of view, and we can use another command for the database by using show IP DHCP snooping database command. So here it will show the entire database of the DHCP snooping. Thank you for attending the session. If you have any queries, let me know in the comment section. And for the complete CCNA course, you can contact us at info@learnedze.com. Thank you.